Hello. We're going to go ahead and do some extra work now with algebraic expressions, algebraic models, linear equations in one variable. Let's start with, let's start with something like this. We're just going to simplify by combining like terms. Negative 9a plus a minus b plus 5a. Remember that like terms have the same variable raised to the same power. So we can take this a term, and this a term, and we can combine those. But this b term cannot be combined with them. Remember that the sign in front of the number, in front of the coefficient, goes with the term. So that's why this is a negative 9 and why this is a plus 5. And recall that when we don't have a number in front of the variable, that's the same as having a 1. So we can imagine putting a 1a. A is just 1a. Minus 1b. B is just 1b. To combine the like terms, we just do the math with the coefficients. Negative 9a plus 1a plus 5a. The number of a's is going to be negative 9 plus 1. That's negative 8. Plus 5, negative 3a. And then we just have this minus 1b, nothing to combine it with, so minus b. We wouldn't want to write negative 3a minus 1b as the final answer because it wouldn't be simplified all the way. Anything times 1 is itself, so 1b means 1 times b. That's just b. So it is incorrect to leave a 1 in the final answer like that. Okay, another one. Let's take a look at 2p minus 7p squared minus 5p plus 6p squared. Now here they're all p. The last one we had a's and we had b's and they couldn't mix. These can't all mix either. Okay, because it's not just the same variable. Remember I said the same variable to the same power. So p's can go together, but p squareds are separate and they can only be combined with other p squareds. Now, you can put the p's first because they come first if you want, but in algebra, it's usually tradition to start with the highest power and work your way down. So I'm going to put the p squareds first. Negative 7 of them plus 6 of them. Negative 7 plus 6 is negative 1. So there are negative 1 p squares. Sorry, negative 1. Negative 7 plus 6 is negative 1. There we go. Wrote it out. All nice there. which means negative 7p squared plus 6p squared is negative 1p squared. And what did we just say? We don't leave negative 1 in the final answer because 1 times p squared is just p squared. So negative p squared is that part. And then 2p's minus 5p's. 2 minus 5 is negative 3. That means 2p minus 5p is negative 3p. And our negative becomes our minus. Remember, our positives and negatives, when we're combining like terms, they become our pluses and minuses that separate the terms of the final answer. Okay, and then we started simplifying with parentheses. And we had to clear the parentheses. Negative 9 minus 4 times the quantity, 2 minus z plus 1. The number in front of parentheses gets multiplied by the parentheses, and it goes through. 2 terms inside, so it goes through to each of them, providing 2 terms of an answer. Everything else carries down. The negative 9 is not involved. You will not do negative 9 minus 4 first. Under no circumstances. That is an automatic 0 points. It is wrong. Order of operations says multiplying comes first. That means clearing these parentheses by multiplying negative 4 times 2 minus z comes first. Let's do that. Negative 4 times positive 2 is negative 8. Negative 4 times minus z, minus times minus is plus. 4z, bring down the plus 1. Again, tradition that we put the highest powered variable first. Since we just have z's and the rest are constants, I'm going to go ahead and move this positive 4z first. And then we have negative 9 minus 8, that's negative 17, plus 1. It's a negative 16. That negative becomes our minus 4z minus 16. Another one. We're going to clear the parentheses first. Combine like terms and simplify. 6y. No, 6 times the quantity. Y minus 2. Minus 3 times the quantity. 2y minus 5. Minus 3. Here's what our distributions are going to look like. So the 6 is going to get multiplied by what's inside the parentheses here and here, but then the parentheses end, so that's it for the multiplying with the 6. This negative 3, the minus stays with the 3. The negative 3 gets multiplied by what's in the parentheses. That's 2 things, so 1, 2. Parentheses end, that's going to be the end of that. And that minus 3 is left over at the end. We're not going to want to forget to put that down before we keep simplifying. Okay. What do we got? 6 times y is 6y. 6 times negative 2, positive times negative is negative 12. That's it for that one. Now, negative 3 times positive 2y. Negative times positive is negative 6y. Negative 3 times negative 5. Negative times negative is positive 15. Then our minus 3. I'm going to put our y's first. We got a plus 6y, minus 6y. Those actually cancel each other out. That leaves 0 there. Negative 12 plus 15 is positive 3, minus 3. Leaves us with nothing. Everything canceled away. It doesn't mean no solution. It just means this all worked out to 0. Saying something like no solution doesn't make any sense here because a solution exists because of an equation. There's no equation here. There's nothing to solve. We are evaluating. We are simplifying. We're simplifying this. This is the same as 0. Okay. Now I'm putting y's and y squareds inside parentheses, but we're going to do the same thing. We're going to simplify this. So here, this is in parentheses, but there's nothing we can do inside. There's nothing on the outside to multiply through. These parentheses are kind of here to trick you, honestly. We don't need them. Nothing's happening to the 2y minus 5. Over here, this negative 2, even though it's red, minus 2 times this, for the purposes of what we're doing, we're going to treat it as a negative 2. We're going to distribute to both of these terms. Negative 2 times y is negative 2y. That negative becomes our minus. Negative 2 times minus y squared. Minus times minus is plus. Negative 2 times negative y squared is positive 2y squared. Then we have minus 3y. I can see these cancel, 2y minus 2y. And that leaves 1 of everything else. So I'm going to take this plus 2y squared, put a positive 2y squared in front, minus 3y minus 5. That's as far as we can take it because y is not the same as y squared. This doesn't have any y's at all. These are not like terms. They cannot be combined any further. We'll do some word problems towards the end of this. In the meantime, I'm going to go ahead and do some practice with equations. And again, a simple equation like x plus 7 equals 19. We want to get the x by itself. What's happening to the x? We're adding 7. How do we get rid of it? We do the opposite. What's the opposite of adding 7? Subtracting 7. An equation has to stay balanced. If we subtract 7 from the left, we have to subtract 7 from the right. stayed balanced, we get our answer of x equals 12. We can keep making this more and more complicated, remember. We're going to get this extra practice in. -3 plus y equals -28. We want to get this y by itself. We want to get this plus y by itself. How do we undo -3? It's not being multiplied, so we wouldn't divide. This -3, is it being added? Do we subtract -3? Well, what if I put it this way? What if instead of -3 plus y, we know we can switch around a plus sign? This would be y plus -3, which would be y minus 3. So looking at it this way, what's happening to the y? We're subtracting 3. A -3 in front, that's not -3y. If it was -3y, yeah, we'd divide because that's multiply. But here, -3 plus y, it doesn't necessarily mean it's being added, but it does mean it's being added or subtracted. And whether it's being added or subtracted is going to come from, is that thing before the plus y positive or negative? Here it's negative. That means it is subtracting 3. We undo subtracting 3 with adding 3. See, we can even see it goes away. -3 plus 3, 0, gone. That just leaves us with our y on the left, -28 plus 3 is -25. And you could always check your answer, remember. You can go back, plug it in. Hey, -3 plus -25, is that -28? Sure is. Adding two numbers with the same sign, we give the same sign. We would add the absolute values together. 3 plus 25 is 28, -28. It does check. That would be right. Two x plus 1 equals 5. Here, there's more than one thing happening. We need to do it in a very specific order. This x that we need to get by itself is currently locked right here into 2x. So we need to get the 2x by itself. We need to do our adding and subtracting before we do that multiplying or dividing. The 2x is having 1 added to it. We undo that with the opposite, subtracting 1 from both sides. Leaves us with just 2x on the left. 5 minus 1 is 4 on the right. Divide both sides by 2 because x is being multiplied by 2. We want to undo that with the opposite. 4 divided by 2 is 2. Now, let's remember what we did when we have something like this. -7/8 equals -5/6 z. We want to get the z by itself, which means we need to undo multiplying by this fraction. Multiplying by a fraction is dividing. Z is being multiplied by the fraction. We need to undo multiplying with dividing by the fraction. Dividing by a fraction is the same as multiplying by the reciprocal. Okay, I said it right that time. So to divide by negative 5/6, we are actually multiplying by the flip of it, negative 6/5. And we're going to do that on both sides. On this right side, where we multiplied by the reciprocal, negative times negative cancels out and becomes positive. 5/6 times 6/5, that all cancels out and becomes 1. So 1 times z just leaves us with z. That's why we multiply by the reciprocal. Gets rid of what we need it to get rid of. On the right, negative times negative is positive. I'll show canceling next. The quickest way is to do 6 times 7 is 42. 5 times 8 is 40. And then reduce that. That's 21 over 20. I can divide top and bottom by 2. I could have also reduced 6/8 to 3/4. 3 times 7 is 21. 5 times 4 is 20. Could have gone straight there. Now I'm going to do another fraction problem, a couple examples from now. And then I'm going to show you a trick that you can do to problems that have fractions and problems that have decimals that can actually get rid of the fractions and decimals for you to make your work easier. It does make them a little more complicated, but if you really don't like working with fractions, if you really don't like working with decimals, you might want to try some out with the trick. But first, let's do a decimal problem. P minus 2.9 equals 3.8. This isn't something you should treat any differently than a normal equation just because it has decimals. It's not these numbers' fault that they have decimals. We want to get rid of subtracting 2.9 to get the p by itself. We do that with adding 2.9. Eight, 9 would be 17. Carry the 1, 4, 5, 6. So p equals 6.7. Three times the quantity x minus 6 equals 2x minus 5. Parentheses are back in our first step. Clear parentheses with the distribution property. 3 times x is 3x. 3 times negative 6, negative 18. On the right, 2x minus 5. I want to get all my x's on the left. I want to get everything else on the right. So I'm going to subtract 2x to get rid of it on the right. I'm going to get rid of a positive 2x with a negative 2x. Whatever I do on the right, I do on the left, and that's how we accomplish the moving. It's gone from the right. 3x minus 2x is just a single x. Minus 18 equals negative 5. We're going to go ahead and get rid of minus 18 with plus 18 on both sides, leaving us just with x on the left. Negative 5 plus 18, that is going to be positive 13. So earlier, I referenced being able to move things around an addition sign. Here's a trick I think you're ready for. Negative 5 plus 18. If we switch it around the addition sign, that's the same as 18 plus negative 5. Adding a negative is subtraction. And I know what 18 minus 5 is. That's 13. That's how I did that. Negative 5 plus 18. Okay. I could figure that out. I could think of the number line. I can think of the rules for adding numbers that have different signs. I can take the absolute values. I can subtract. I can see that the larger absolute value was the 18. It was originally positive. So my answer is positive 13. Or I can just see that I have a plus sign here, and that if I switch the two numbers, things become easier. So I did that. Once you know the basics, you can start exploring tricks. If you are already just doing everything with negative numbers with calculator, and not even trying to do these skills by hand, this algebra sequence is going to get harder and harder for you. The more reliant you are on a calculator, the less knowledgeable you are on the rules, and less knowledgeable you are on the rules, the harder it is to understand why we're doing things as we move forward, and as a calculator helps less. It's best to get all those rules down and understand them when we're just dealing with numbers like this.
The third objective in this topic is solve linear equations containing fractions or decimals.
Let me take a look at this problem now. This is going to be very scary looking. I'm sorry in advance. 2/3 x minus 1/6 equals negative 5/12 x plus 3/2 minus 1/6 x. Wow. So there's a fraction in every little bit of this problem. What we can do working with fractions, since we know we're going to need to be adding and subtracting, is we can start by giving everything a common denominator. So for 3, 6, 12, and 2, we would need to find a number that is in common to all of the lists of multiples. And it shouldn't be too difficult to figure this out. I'm going to write them out, but you might have been able just to look at it and see that that number is going to be 12. It's the first one to appear in every list of multiples. So we can rewrite all of our fractions in the problem. Oops. Don't do what I was about to write. That makes no sense. The new bottoms are 12. That's going to change almost all of the tops. The only one that's not going to change is this one, because it's already a 12. Okay, so now we need to figure out the new top numbers. How do we do that? How do we find equivalent fractions? Well, remember, whatever we do to get the bottom number, we have to do to get the new top number. So 3 times 4 gives us 12. 2 times 4 gives us 8. 6 times 2 gives us 12. 1 times 2 gives us 2. 2 times 6 gives us 12. 3 times 6 gives 18. 6 times 2 is 12. 1 times 2 is 2. Now there's nothing I can combine on the left side. This is an x term. This is not an x term. They are not like terms. They can't be combined. Over here, the middle term doesn't have an x, but these ones do. So I can write this more simply. Negative 5 minus 2 is negative 7/12 x plus 18/12. Copy everything else down. So again, negative 5 of these 12th minus 2 of these 12ths is going to give me negative 7 of these 12ths, and that was the coefficients of x. The 18/12 just carries on. Now, from here, I'm going to move any x terms I have to this side by getting rid of them. Here we have a minus 7/12 x plus, so it's either being added or subtracted. Right now it's being subtracted because of the minus. We will undo it by adding 7/12 x to both sides. So plus 7/12 x in there. I'm going to go ahead try to get it on the screen. Yeah. Plus 7/12 x. 7 plus 8 is 15/12 x minus 2/12 equals, these are gone. All that's left is positive 18/12. So again, I combined like terms, and then I added 7/12 x to both sides to get rid of it here. When I added the 7/12 x to the 8/12 x, I got 15/12 x. Now, I want to get rid of minus 2/12. I'm going to add 2/12 to both sides. That's going to get rid of this here. I'm going to erase. Wow, so fractiony, this problem. It's going to leave me with just 15/12 x on the left. On the right, 18/12 plus 2/12 is 20/12. We can go ahead and multiply by the reciprocal to get the x by itself. To get rid of 15/12, we would have, I'm going to use a different color again. We'll multiply by 12/15, because that'll get rid of everything here and just leave us with x. On the right, these 12s cancel. We're left with 20/15. Both of those can be divided by 5. So our answer, x is 4/3. Now, we did a lot of fraction work to get there, and I said, don't worry. I'm going to show another way. A way where you don't have to worry so much about the fractions. So same problem. 2/3 x minus 1/6 equals negative 5/12 x plus 3/2 minus 1/6 x. We found a least common denominator. We found the least common multiple of 2, 3, 6, and 12 to be 12. When we made the lists, we saw 12 was the first one that was in all 4 of them. I'm going to go ahead and take every one of these 5 terms, and I am going to put a factor of 12 in the top of each. Now, before I do that, let me take a moment to explain why that works. So we have the ability to take an equation, something's there, something's there. And if we wanted to, we can multiply 12 by both sides. Well, as a fraction, 12 is 12/1. If these things that we're multiplying by have parentheses, then this 12/1 gets multiplied by each of the terms inside. It gets distributed. So I'm just skipping those steps, and I'm just jumping to the result, which is there's going to be a times 12 in the top of every term. And it's all perfectly legal because it's multiplying both sides by 12. The end result is we take this 12 and we go 12 times 2/3x. So instead of 2/3 x, I put a times 12 in there. Minus, instead of 1/6, I put a times 12 in there. Instead of negative 5/12 x, I put a times 12 in there. Wow, this is like a catchphrase right now. Instead of 3/12, instead of 3/2, I put a times 12 in there. And you guessed it, instead of 1/6 x, what do you think I'm going to do? I'm going to put a times 12 in there. So because I did it to every term, that's the same as doing it to both sides and distributing it through. Only in the top, because 12 is 12/1. A times 1 is what got put in each of the bottoms. But of course, that doesn't change anything. So why worry about it? Times 1 is itself. Now, because we specifically used 12, because it was a common denominator, a common multiple of all the denominators, it's going to get rid of all the fractions now. What do I mean? 12/3, that's 4. So let me express this with a different color. I'll use blue for the canceling here. 12/3, that's going to be 4 times 2x. And then we have a minus 12/6. 12 divided by 6 is 2. So that's going to be a 2 times 1. Okay. equals 12 over 12. That's 1. Those cancel out completely. So minus 5x. 12 over 2. That's a 6 times that 3. And then 12 over 6, that is a 2 times that 1x. Look, all the fractions are gone. When I simplify this, 4 times 2x is 8x, minus 2 times 1, that's minus 2. Negative 5x plus 6 times 3, that's plus 18, minus 2 times 1x, that's minus 2x. All the fractions are gone. If I combine like terms here, minus 5x minus 2x, that's minus 7x plus 18. If I add 7 to both sides, plus 7x plus 7x, that's 15x minus 2 equals 18. Look at this, no fractions. Add 2 to both sides. Just leaves 15x on the left, 20 on the right. Divide both sides by 15. 20 over 15 reduces to 4/3. X equals 4/3. Same answer we got dealing with fractions the whole time. So if you're more comfortable working to get rid of the fractions first before we add and subtract them around, you can do that using that trick, and you will get the same answer. Let's do some practice with this. Let's look at negative 1/2 y plus 4 equals negative 9/10 y plus 2/5. If I look at the numbers that's on the bottom of all the fractions, 2, 10, 5, the least common denominator is going to be 10. I'm going to go ahead and put a times 10 in every term. I'm going to include this one. Because remember, 10 times the whole side would get distributed. Even if it's not a fraction, you still need to multiply your 10 by it. And if it is a fraction, it just goes in the top. So, leaving room for a times 10, there's my rewriting, and I'm going to go through times 10, times 10, times 10, times 10. Ten over 2 leaves me with 5. So this is going to be negative 5y plus 40 equals 10 over 10 cancels. So that's minus 9y. 10 over 5 is 2. 2 times 2 is 4. So right there, now we have it without any fractions. We can solve. I'm going to add 9y to both sides. Negative 5y plus 9y is positive 4y. Plus 40 equals 4. From 4y plus 40 equals 4. Subtract 40 from both sides. We get 4y equals negative 36. Divide both sides by 4. We get y equals negative 9. We didn't have to work with fractions once we got rid of them. What we are allowed to do is check our answer, because maybe you got a little nervous because maybe you don't think you cleared the fractions right or something like that. Well, how can you check and make sure you have the right answer? We can take the original problem. We can plug negative 9 in for y. The checking is going to involve some fraction work. You don't have to check if you just want to risk it. Okay, so I plugged in negative 9 for the two y's. Negative times negative is positive. 1/2 times 9 is 9/2 plus 4 equals negative times negative is positive. 9 times 9 is 81. So this is what we're checking. 4 would be 4 over 1, would be 8 over 2. 9 over 2 plus 8 over 2 on that side. On this side, 81/10. 2/5 would be 4/10. So over here on the left, that's 17/2. Over on the right, 85/10. How can we check and see if these are the same fraction? Well, 2 times 5 is 10. Is 17 times 5 85? Yes, it is. These are the same fraction. This does check. So y equals negative 9 is the answer. But again, you might be hesitant to check there because if you did it to avoid the fractions, you're not going to want to check this. But you are expected to know how to do this. So even if you're not comfortable with it right now, you need to get more comfortable with fractions. But in dealing with fractions, clearing using that LCD trick where you find the least common denominator and then put it in the top of every term, that'll at least be a strategy you have that can cut down on the fraction work. We have a similar trick with decimals. If we have 6.3w minus 1.5 equals 4.8, working with decimals, we would add 1.5 to both sides to get rid of it here. That's 6.3w equals 6.3. And we lucked out here because if we divide both sides by 6.3, instead of being a difficult decimal problem where we're dividing by 6.3, we end up with something divided by itself and we get 1. But let's see how we can get that same answer without doing any work with decimals at all. So same problem, minus 1.5. We can go to every term, every single term, and move the decimal point by the number of times it would take to get rid of all decimals in the problem. So here it would require 1 everywhere, because that's going to turn each of these into a whole number. It's going to turn 6.3 into 63W. It's going to turn 1.5 into 15. It's going to turn 4.8 into 48. And then boom, no more decimals in the problem. Add 15 to both sides. No decimals to worry about. 63W equals 63. Divide both sides by 63. No decimal to worry about. W equals 1. So more practice here. Okay. (0.4 times the quantity n plus 10 plus 0.6 n equals 2. Normally, when we do this problem, this 0.4 would get distributed to both of these terms. Keeping that in mind, when we're going to do our decimal trick, we're not going to touch what's inside the parentheses. We're only going to move the decimal out here because the distribution is going to take care of filtering it through to the inside. So how many terms do we have here? 1, 2, 3. That's it. Don't count what's in here and don't count these separately. These are two things multiplied by each other. That means they're factors. Together, this is a term, one single term, because terms are separated by pluses and minuses. 1, 2. And on the other side, we have 3. So 3 places we have to move the decimal points. In order to turn them into whole numbers, 1 is all that's going to be required. We don't see a decimal point there, but we give it to ourselves. 4 times the quantity n plus 10 plus 6n equals 20. Now we can distribute. Look at that. The decimals are all gone because of our trick. 4n plus 40 plus 6n equals 20. Combine like terms. 10n plus 40 equals 20. From up here, that same step. Subtract 40 from both sides. 10n. 20 minus 40, negative 20. Divide both sides by 10, and we get our answer, negative 2. If we would have done it with the decimals, we would get the same answer. You don't have to use this trick. You can keep everything in decimal form. So same problem, 0.4 times n plus 10 plus 0.6n equals 2. Distribute, we would have 0.4 times n plus 10 times 0.4. That's just 4 plus 0.6n equals 2. 0.4n plus 0.6n is 1n, just n, plus 4 equals 2. Subtract 4 from both sides, same answer. N equals negative 2. So this one wasn't so bad because it worked out to adding to a whole number. But you can see we do get the same answer whether we shift decimal points or not. The reason it all has to be the same number is because moving a decimal point one place to the right is the same as multiplying by 10. 2 places, multiplying by 10 again, so multiplying by 100. That's why you can't do just 2 on one side, but 1 on the other, or maybe 2 on one side, but 3 on the other. You have to figure out what the maximum number is that gets you through, gets everything to a whole number. And if you need one of them to go 3 times, then you need to send all of them 3 times.
Objective 5 in this topic is recognize identities and equations with no solution. Now, recognize doesn't mean just look at it and, hey, I recognize this. This is a no solution thing. You've got to do a little bit of work to get there. But that work is what we've already been doing. We see parentheses. We want to get rid of parentheses. We distribute. 3 times x plus 3 times 1 gives us 3x plus 3 on the right. Maybe you recognize it at this point. If not, we continue. What would we do? Well, we want to get our x's on one single side. So let's subtract 3x from both sides. But when we do that, the x's go away. You're not missing something except your x because it's not supposed to be there because it went away. And because the x went away, don't get self-conscious and be like, but I need an x, so I just put an x somewhere. No, it's okay that the x is gone. 3x minus 3x is 0 on both sides. 0 minus 7 is negative 7. 0 plus 3 is 3. Our equality now really does say negative 7 equals 3. This does not mean x equals negative 7. This does not mean x equals 3. It literally means negative 7 equals 3. And hopefully you push back on that and you go, but hey, negative 7 does not equal 3. You can't convince me of that. Since no value for the variable x can be substituted into this equation that will make this a true statement, there is no solution. The solution set is written either as literally an empty set or this symbol for the empty set, a 0 with a slash through it. The equation is a contradiction. So there's no solution there. We can never make negative 7, 3. You were correct. Five x minus 5 equals 2 times the quantity x plus 1 plus 3x minus 7. There is a lot going on there. Don't be overwhelmed. Follow the process. Get rid of the parentheses first. 2 times the quantity x plus 1. Distribute. That becomes 2x plus 2. Everything else gets copied down the same. There's nothing we can do on the left currently. On the right, there is some combining that we can do. 2x plus 3x is 5x, and positive 2 minus 7, the number takes the sign in front, so this is a positive 2, this is a minus 7, no matter what. 2 minus 7 is negative 5. So 5x minus 5 is what we get on the right. Hey, wait a minute, that's exactly what we had on the left. Maybe we realized something at this point. Maybe we don't, in which case we continue. Subtract 5x from both sides, add 5 to both sides, we get 0 equals 0. Or maybe we stopped when it said negative 5 equals negative 5. Or maybe, right here when it said 5x minus 5 equals 5x minus 5. I said maybe you noticed at that point. Whenever we get the exact same thing on both sides, that is always true. No matter what we start with for x, we're going to end up with a true statement. So both sides of the equation are identical. Since this equation will be true for every x that is substituted into the equation, the solution is all real numbers. This can be written as in set builder notation, the set of all x such that x is a real number. This equation is called an identity when this happens. Remember what I said much earlier. Identity means same. So the same thing on both sides is an identity. And you could also write all real numbers as the R with the 2 lines going down on the left side of the R. You'll also learn that you can write it in interval notation, which would be parentheses, negative infinity, comma, infinity, close parentheses. But you don't know that yet. So for now, just say all real numbers. That is it for this topic. If we ever solve an equation and we get something equal to itself, the same on both sides, not checking it, not getting our answer and then plugging it back in to see if we're right, but in the process of getting our answer, if the variable disappears and we just have a true statement, 3 equals 3, we have an identity. An example of such things now, there's no way to know when you start that you're going to get an identity. You just have to be able to recognize it when it happens. Okay, let's solve this for C. Well, first we'd clear parentheses and combine like terms. So distribute. 5 times 3 is 15. 5 times C plus 2
Combine like terms here. 2c plus 3c is 5c plus 17. Still got one more thing we can combine here. 15 plus 2, so 17 plus 5c equals 5c plus 17. And maybe right here you notice this is the same. But our next step in solving, clear parentheses, combine like terms. Once you can't combine like terms anymore, to get all the variables on one side. So I'm going to go ahead and subtract my 5c from here, from both sides to keep it balanced. But look, all the c's go away. And it says 17 equals 17. This does not mean that the answer is c equals 17. This does not mean that. There is no more c. The c's are gone. 5 minus 5 is 0. 5c minus 5c is 0c, 0. But we're left with 17 equals 17, which is an identity. When this happens, the answer is all real numbers. Or you can just have the set big R, all real numbers. That means that you can plug anything in for C and it will always be true. That doesn't mean that if you have the wrong answer, since you can plug it in and check and it works out and it's right, that doesn't mean you're right. If I put 17 in, it would work. But if I put 2 in, it would work. If I put -8 in, that would work. All real numbers would work, so all real numbers is the answer. And we know that because we get the same thing. The opposite of an identity is a contradiction. So up until now, we've had conditional equations. That means we got one answer. It's only true if this answer, or maybe there's one that has a couple answers. We don't do any of those in this class. But there's a small finite number of answers to the equation, and those have to be what the variables are, or it's not true. Now we have identities. Those are ones when we get a true statement at the end with just numbers, and they are always true. So all real numbers. The opposite of an identity is a contradiction. In other words, you'll get something that is never true. For example, two times -5x minus 1 equals 2x minus 12x plus 6. If we solve here, distribute to get rid of the parentheses. 2 times -5x is -10x. 2 times -1 is -2. Equals, combine like terms. 2x minus 12x is -10x plus 6. I'm going to go ahead and add 10x to both sides to move my x's from the right to the left. Gets rid of them on the right, leaving me with just a +6. But it also gets rid of them on the left. All variables are gone. And I get -2 equals 6. This is not true. This is a contradiction. This means no matter what you plug in, you're never going to get a true statement because -2 does not equal 6. And the answer is the empty set, or no solution. Okay, that's it for this session. I will see you next time.